Let us try to visualize this formula for calculating probability of union of three non-disjoint events using Venn diagram model of probability, and also see how this is a general equation of this special case, which is more of a common form of equation to be known. For understanding this, what we will do is add series of partially intersecting circles of certain color whose area represents the probability of the respective event, and our goal for this will be to make entire area of the circles of uniform shade. Let us see what I mean by that. First, we begin by adding the first circle representing probability of event A, and notice that it occupies these two double convex shaped areas, which also happens to be the part of this oddly looking middle section. Then we add circle of event B, which contributes to these two convex areas. But now notice that unknowingly what we have done is we also added this middle convex region twice. First time when the event circle of A got added, and then second time when the event circle of B got added, leading to shade of the color to go a bit brighter. Now let us move on to adding third circle of event C, which this time adds one extra portion to both of these convex areas, which belongs to this event circle A as well as event circle B. So in a nutshell, we have added each of these three convex shaped areas two times, which belong in common to either of two of these three circles, which is as if we have over accounted for each of these three convex areas at least once. Okay, now what about the middle section then, which is common to all three circles? It seems to be appearing even brighter than other three convex areas. To find out why, let's revert back the time and focus only on middle intersection area, which is intersection of all three circles. We find that it got added first time when we add the first circle, and then second time when we added the second circle, and then the third time when the third circle was added. So in and all, we have over accounted for the middle section, which is a part of triple intersection, at least two times. Now moving on to calculating the probability of union formed by these three circles, we need to first subtract back the extra intersecting areas that we added when each circle got introduced into our equation. To just do that, let us first take away the area formed by intersection of event circle A and B, and while we do that, notice we also inherently took the middle area away, and now it appears that some of the region has been normalized to uniform color. Now let's take away the intersection of event circle B and C, which again makes us automatically remove the middle intersection area, leaving a much bigger part of the total area at uniform color. So till now, we have removed the extra added parts of two of the double intersecting areas, and while doing so, we also removed the middle area twice, which was over counted by exactly same amount, which is two times, thus now making the middle section entirely in sync of the color with the rest of the area. Now what is left is to take away the third double intersecting area, which is between circle A and C, which if we do take away, we also tear off what is left of this middle area, which is as if we tore apart the middle part completely, leaving a void space in between. But except that, now we realize leaving the middle area aside, the entire part of our Venn diagram is at exact uniform color. So if we were to just add this middle section back, which is intersection of all three event circles, we now obtain the perfect union of three circles, eliminating the overcounting of each intersecting areas, which now have uniform color shade. And this is how we visually conceptualize the given form of our formula. Okay, now what about this special case then, where we just have these single probability terms? Well, it simply implies that this case belongs to probability of union of disjoint events, meaning that there are no intersecting regions between the three events. So for illustrative purpose, if I make use of square areas representing probability of each event, just because it facilitates the point more clear visually, and after having them arranged such that there is no common intersecting events between those event squares, then taking union of those involve no subtracting of overcounted parts as they don't exist at first place. So every term leaving the individual probability terms gets washed away, and we are left with this simple looking formula, which turns out to be the special case of this more generalized equation.